Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you found the right place. Before we begin, I'd love to know where in the world are you listening from. Perhaps you're wrapped in a blanket, sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into the vast reaches of our outer solar system, where something impossible stirs in the ancient orbit of Comet 3I Atlas. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. Far beyond Neptune's orbit, where sunlight arrives as the faintest whisper and temperatures hover just above absolute zero, a wanderer moves through the cosmic dark. Comet 3I Atlas follows its elliptical path with the patience of geological time itself, tracing the same gravitational groove it has carved for 4.5 billion years. This is the realm of dirty snowballs and primordial ice, where comets drift like sleeping giants, their surfaces untouched by the warmth that stirs the inner planets into motion and change. The comet measures roughly 12 kilometers across its longest axis, a modest size by cosmic standards, yet it carries within its frozen heart the original materials from which our solar system condensed. Water ice mingles with carbon dioxide and methane, all locked together with silicate dust and organic compounds that predate Earth itself. Its surface bears the gentle scars of micrometeorite impacts accumulated over eons, creating a landscape of subtle craters and ridges that catch starlight like a forgotten sculpture carved from primordial frost. At this distance from the Sun, nearly 40 astronomical units away, solar radiation provides less energy per square meter than a birthday candle would offer from across a football field. The comet's surface temperature remains locked at -230 degrees Celsius, so cold that molecular motion nearly ceases entirely. Here, time moves differently. Chemical reactions that might occur in milliseconds on Earth require millions of years to complete. The comet's rotation period stretches across 18 Earth hours, a leisurely tumble that has remained unchanged since the solar system's formation. Scientists have catalogued thousands of comets in their predictable orbits, each one a time capsule from the solar system's violent birth. They understand the physics of sublimation, the way solar radiation transforms ice directly into vapor without passing through liquid form, creating the characteristic coma of gas and dust that surrounds an active comet's nucleus. They know how solar wind, that constant stream of charged particles flowing outward from our star, shapes the magnificent tail that always streams away from the Sun. Regardless of the comet's direction of travel, they can calculate orbital mechanics with extraordinary precision, predicting exactly when and where a comet will appear in Earth's sky decades or even centuries in advance. The Kuiper Belt, that vast ring of icy debris beyond Neptune's orbit, houses perhaps 100,000 objects larger than 100 kilometers across, and millions more of smaller sizes. These remnants from the solar system's formation period drift in near-perfect preservation, their interiors unchanged since the primordial disk of gas and dust first began to condense around our young Sun. When gravitational perturbations occasionally nudge one of these frozen wanderers inward toward the inner solar system, astronomers can predict with remarkable accuracy how it will behave as solar heating begins to transform its surface. Comet 3I Atlas belongs to this ancient family of long-period comets, those whose orbits stretch so far from the Sun that they require thousands of years to complete a single journey. Its last close approach to the inner solar system occurred during humanity's Bronze Age, when civilizations were just beginning to develop written language and metallurgy. No human eyes witnessed its previous passage, No instruments recorded its behavior, no calculations predicted its return. For most of human history, 3I Atlas existed only as a point of reflected starlight, moving imperceptibly against the background constellations. Yet something about this particular comet has begun to whisper that their understanding, complete as it seems, might be beautifully incomplete. Deep space monitoring stations have been tracking 3I Atlas for the past 18 months as it approaches its perihelion, its closest point to the Sun, still more than 3 billion kilometers away. The comet should remain essentially dormant at this distance, showing no signs of the activity that characterizes comets when they venture into the inner solar system. Its surface should remain frozen solid. Its orbit should follow the precise mathematical curve calculated from Newton's laws of gravitation and motion. Instead, something impossible has begun to happen. The first anomaly appeared as a subtle brightening detected by automated sky surveys designed to identify potentially hazardous asteroids. 3I Atlas, which should have remained invisible to all but the most powerful telescopes, suddenly increased in brightness by nearly 2 magnitudes, becoming 4 times more luminous than predicted. Astronomers initially attributed this to outgassing from a fresh impact crater, or perhaps the collapse of a cliff face exposing fresh ice to space. Such events, while rare, fall within the range of normal cometary behavior, but the brightening continued. Week after week, 3I Atlas grew more luminous, developing a faint coma of gas and dust that extended thousands of kilometers from its nucleus. Spectroscopic analysis revealed the characteristic signatures of sublimating water ice, carbon monoxide, and methane normal cometary materials behaving in completely abnormal ways. The temperatures required for such extensive sublimation simply do not exist at the comet's current distance from the Sun. Only took 4 billion years for this ancient wanderer to reach this point in its journey. Only took humanity a few centuries to think they understood comets entirely. Only took one small deviation from predicted behavior to suggest that the universe still keeps its deepest secrets locked in ice and stone, waiting for the right moment to reveal that impossibility and wonder remain the fundamental constants of cosmic truth. As 3I Atlas continues its ancient pilgrimage through the outer darkness, something stirs within its frozen core, something that will soon challenge every assumption about the nature of cometary behavior and the quiet predictability of celestial mechanics. The comet moves through space like a question mark written in ice and starlight, carrying mysteries that predate human civilization and perhaps human understanding itself. The orbit of Comet 3I Atlas stretches across the solar system like a cosmic ellipse drawn with mathematical precision, its path determined by gravitational forces that have remained constant since the planets first settled into their current configurations. For 4.5 billion years, this frozen wanderer has followed the same trajectory, neither speeding up nor slowing down beyond the predictable variations caused by the Sun's gravitational pull. At aphelion, its most distant point, the comet ventures nearly 50 astronomical units from the Sun, well beyond the orbit of Pluto, into the realm where solar influence becomes barely perceptible, and interstellar space begins to assert its cold dominance. The comet's orbital period spans approximately 4,200 years, a time frame that encompasses the rise and fall of entire human civilizations. When 3I Atlas last approached the inner solar system, the Great Pyramid of Giza was already ancient, and the Library of Alexandria had not yet been conceived. Its previous passage occurred during the collapse of the Bronze Age, when mysterious sea peoples swept across the Mediterranean and the Mycenaean civilization crumbled into legend. No human observer recorded its appearance then. No instruments measured its brightness. No calculations predicted its return. During its long journey through the outer solar system, 3I Atlas experiences conditions that would be utterly alien to terrestrial life. For 99% of its orbit, the comet remains frozen in a state approaching absolute zero, its surface temperature hovering around -240 degrees Celsius. At these temperatures, even hydrogen becomes sluggish, and molecular motion nearly ceases entirely. The comet's rotation continues with metronomic precision, completing one revolution every 18 hours and 14 minutes, a rhythm established during the solar system's chaotic formation period and maintained ever since through the conservation of angular momentum. The nucleus itself represents a museum of primordial materials, its interior preserving chemical compounds and isotopic ratios that date back to the solar nebula from which our entire planetary system condensed. Deep within its core, layers of different ices record the temperature and composition of the early solar system, like tree rings preserve climate history. Water ice dominates the composition, but frozen carbon dioxide, methane, ammonia, and complex organic molecules create a heterogeneous mixture that varies from layer to layer. These materials formed in the cold outer regions of the solar nebula, where temperatures remained low enough for volatile compounds to freeze solid and accumulate into planetesimals. Gravitational perturbations from Jupiter and the other giant planets occasionally nudge long-period comets like 3I Atlas from their distant orbits in the Oort cloud and Kuiper belt, sending them on trajectories that bring them closer to the Sun. This process occurs randomly over geological timescales, with some comets being ejected entirely from the solar system, while others settle into shorter orbital periods. The precise mechanism that originally deflected 3I Atlas into its current orbit remains unknown, lost in the chaotic dynamics of the early solar system when planetary migration and gravitational resonances reshape the architecture of cosmic space. As the comet follows its predetermined path, it encounters the solar wind, that constant stream of charged particles flowing outward from the Sun at speeds exceeding 400 kilometers per second. Even at 3I Atlas's current distance, this tenuous plasma exerts measurable pressure on any object in its path. For most of the comet's orbit, this interaction remains negligible, producing no observable effects on the frozen nucleus. The solar wind simply flows around the comet like a river around a stone, carrying away occasional atoms knocked loose by cosmic ray impacts. Astronomical observations have tracked thousands of similar objects over the past several centuries, building a comprehensive understanding of cometary physics and orbital mechanics. The gravitational influence of each planet can be calculated with extraordinary precision, allowing astronomers to predict cometary positions years or even decades in advance. When Comet Halley approaches the inner solar system every 76 years, its arrival time can be predicted to within hours. The orbital mechanics that govern these cosmic wanderers represent some of the most thoroughly understood phenomena in astronomy. Yet, something about 3I Atlas has begun to deviate from these well-established patterns. The first subtle anomalies appeared in orbital tracking data collected over the past several months. The comet's position, when compared to calculated predictions, showed minute discrepancies that fell just outside the margin of observational error. Initially, astronomers attributed these differences to measurement uncertainties or perhaps unaccounted gravitational influences from distant objects. Such small deviations occur regularly in astronomical observations and rarely indicate anything more significant than the limits of instrumental precision. But the deviations have continued to grow. Each successive observation shows 3I Atlas moving slightly faster than its calculated orbital velocity should allow, as if some unknown force were accelerating the comet along its trajectory. The effect remains subtle, a difference of perhaps a few meters per second in an object moving at 24 kilometers per second relative to the Sun, but it represents a clear violation of Newtonian mechanics and conservation of energy principles. Cometary outgassing can produce small, non-gravitational forces as sublimating materials create tiny rocket-like jets from the nucleus surface. This phenomenon, known as the Yarkovsky effect, has been observed in many active comets and can be incorporated into orbital calculations. However, 3I Atlas remains too distant from the Sun for significant outgassing to occur, and the observed acceleration exceeds what could be produced by even the most vigorous sublimation processes. Only took 4 billion years for this trajectory to become as predictable as clockwork. Only took a few months of observations to reveal that clockwork might be more mysterious than anyone imagined. Only took the slightest deviation from calculated predictions to suggest that some force beyond gravity and momentum might be stirring within the ancient nucleus. The comet continues its patient journey through the cosmic dark, carrying within its frozen heart secrets that predate human understanding of celestial mechanics. Something within 3I Atlas has begun to awaken, introducing variables into equations that were thought to be complete, transforming a routine astronomical observation into a puzzle that challenges the fundamental assumptions about how objects move through space and time. The first definitive sign that something unprecedented was occurring with Comet 3I Atlas appeared on the night of March 15th, when automated sky survey telescopes detected a brightness increase that defied every model of cometary behavior developed over the past 3 centuries. The comet, which should have remained a faint smudge of reflected starlight visible only to the most sensitive instruments, suddenly blazed forth with an intensity that increased by nearly 4 magnitudes in less than 72 hours. This transformation represented a 16-fold increase in luminosity, as if someone had switched on a cosmic lighthouse in the outer darkness of the solar system. Dr. Elena Vasquez, monitoring the automated detection systems at the Catalina Sky Survey, initially assumed the brightening indicated a computer error or perhaps contamination from a nearby star. Comets simply do not exhibit such dramatic activity at distances exceeding 30 astronomical units from the Sun, where solar radiation provides insufficient energy to drive the sublimation processes that create cometary brightness. The surface temperature of 3I Atlas, even accounting for seasonal variations and rotational heating, should have remained locked at approximately -235 degrees Celsius, far too cold for any significant outgassing to occur. Yet subsequent observations confirmed the impossible reality. Night after night, 3I Atlas continued to brighten, developing a visible coma of gas and dust that extended thousands of kilometers from its nucleus. High-resolution imaging revealed delicate streamers of material flowing away from the comet's surface, creating structures that resembled the early stages of tail formation typically observed only when comets venture within 2 astronomical units of the Sun. The coma displayed a distinctly asymmetric shape, with jets of material preferentially erupting from the comet's northern hemisphere in patterns that suggested complex subsurface processes. Spectroscopic analysis provided even more puzzling data. The characteristic emission lines of sublimating water ice appeared prominently in the comet's spectrum, accompanied by signatures of carbon monoxide, methane, and more exotic compounds, including hydrogen cyanide and formaldehyde. These materials require specific temperature thresholds to transition from solid to gaseous phases, thresholds that thermal models indicated should not exist anywhere on or within the comet's nucleus at its current distance from the Sun. The observed sublimation rates suggested internal temperatures approaching -150 degrees Celsius, nearly 100 degrees warmer than solar heating alone could possibly provide. The mystery deepened when astronomers calculated the total energy budget required to sustain such extensive outgassing. The amount of material being ejected from 3I Atlas each second exceeded 100 kilograms, creating a mass loss rate that would completely erode the comet's nucleus within several thousand years if maintained continuously. This rate of sublimation required energy input equivalent to several million watts, roughly comparable to the electrical consumption of a small city, yet no known mechanism could account for such prodigious energy production within a presumably inert ball of ice and dust. Radiometric observations using infrared telescopes revealed additional anomalies in the comet's thermal emission patterns. Rather than displaying the uniform cooling expected from an object heated only by distant solar radiation, 3I Atlas showed distinct hotspots distributed across its surface in geometrically regular patterns. These thermal anomalies appeared to pulse with rhythmic variations, growing brighter and dimmer over periods of approximately 6 hours, 1/3 of the comet's rotation period, as if some internal clock were regulating the heat production mechanisms. The International Astronomical Union convened an emergency committee to coordinate observations and develop theoretical explanations for the unprecedented behavior. Multiple observatories redirected their instruments toward 3I Atlas, collecting data across the entire electromagnetic spectrum from radio waves to gamma rays. Each new observation revealed additional layers of mystery, as the comet's behavior continued to violate fundamental assumptions about cometary physics and thermodynamics. Attempts to model the observed phenomena using conventional cometary science produced only contradictions and impossibilities. Impact scenarios, which might explain sudden outgassing through the exposure of fresh subsurface materials, could not account for the sustained nature of the activity or the regular patterns observed in the thermal emissions. Radioactive decay of heavy elements within the nucleus might theoretically provide internal heating, but the isotopic abundances required would be millions of times higher than observed in any other solar system object, including meteorites that preserve samples of primordial materials. The most exotic proposed mechanism involved crystalline phase transitions within the ice matrix, a process that could theoretically release stored energy as the comet's internal structure reorganized under the influence of cosmic radiation accumulated over billions of years. However, laboratory experiments and theoretical calculations suggested that such transitions would occur gradually over geological timescales. Not in the dramatic burst observed in 3I Atlas, the energy release rates simply exceeded what any known physical process could sustain within a cometary nucleus. As weeks passed and the brightening continued, astronomers began to acknowledge that they were witnessing something genuinely unprecedented in the documented history of cometary observations. The meticulous records maintained by Chinese astronomers over more than 2 millennia contained no accounts of similar behavior, nor did the comprehensive catalogues compiled by European observers since the Renaissance. 3I Atlas had entered uncharted territory, exhibiting phenomena that challenged the fundamental understanding of how icy bodies behave in the cold vacuum of space. Only took 3 centuries of systematic cometary observation to establish the basic physics of sublimation and outgassing. Only took 1 night of automated sky surveys to detect behavior that invalidated those carefully constructed theories. Only took a few weeks of detailed observations to confirm that the impossible had indeed become manifest in the ancient nucleus of a wandering ball of primordial ice. The comet continues its brightening as it moves through space, each passing day revealing new layers of mystery that deepen rather than resolve the fundamental questions about what force or process has awakened within its frozen heart. Something stirs in the darkness beyond Neptune's orbit, something that transforms the predictable clockwork of celestial mechanics into a cosmic puzzle that may require entirely new physics to comprehend. The fundamental physics of sublimation had been understood with crystalline clarity for more than 2 centuries, ever since scientists first observed how solid materials transition directly to gaseous phases without passing through liquid intermediates. Water ice, The primary constituent of cometary nuclei requires a minimum temperature of approximately -130 degrees Celsius to begin sublimating at the vacuum pressures of space. This threshold represents an absolute physical boundary, determined by the binding energy between water molecules and the thermal motion required to break those bonds and release individual molecules into the surrounding vacuum. At Comet 3I Atlas's current distance from the Sun, surface temperatures should remain locked at -235 degrees Celsius, more than 100 degrees below the sublimation threshold for water ice. Even accounting for the comet's dark surface materials, which absorb solar radiation more efficiently than pure ice, thermal models indicated maximum temperatures approaching -200 degrees, still far too cold for any significant phase transitions to occur. The comet should have remained dormant, its surface locked in primordial stillness, with perhaps occasional atoms knocked loose by cosmic ray impacts or micrometeorite collisions. Yet, the impossible was occurring with systematic precision. Spectroscopic observations revealed emission lines corresponding to water vapor streaming away from the nucleus at rates exceeding 100 kilograms per second. This represented not merely trace sublimation, but vigorous outgassing comparable to comets approaching within 1 astronomical unit of the Sun. The water molecules displayed kinetic energies consistent with temperatures approaching -150 degrees Celsius, impossible temperatures that violated every thermal model of cometary heating mechanisms. The mystery compounded when astronomers detected sublimation signatures from materials with even higher energy thresholds than water ice. Carbon monoxide, which requires temperatures above -200 degrees to sublimate significantly, appeared prominently in the comet's spectrum alongside methane, ammonia, and complex organic compounds. These observations suggested that entire regions of the nucleus had somehow warmed to temperatures that should not exist anywhere within 3I Atlas's structure, as if some internal furnace was selectively heating different chemical reservoirs according to an unknown schedule. High-resolution imaging revealed the spatial distribution of this anomalous sublimation, showing distinct jets of material erupting from specific locations on the nucleus surface. These jets did not emerge randomly, but appeared to originate from geometrically regular positions, forming patterns that suggested underlying structural organization within the comet's interior. Some jets remained active continuously, while others pulsed with rhythmic variations tied to the nucleus's rotation period, as if valves were opening and closing in response to some internal timing mechanism. Thermal infrared observations provided even more puzzling data about the energy processes driving this impossible sublimation. Rather than displaying the uniform temperature distribution expected from solar heating, the nucleus showed distinct thermal anomalies that appeared to move across its surface in patterns unrelated to its rotation or orientation relative to the Sun. These hotspots reached temperatures of -120 degrees Celsius, warm enough to drive vigorous sublimation, yet inexplicably isolated from any external heat source. The total energy budget required to sustain such extensive sublimation exceeded the entire thermal output that solar radiation could deposit on the comet's surface by factors of hundreds. Even if 3I Atlas absorbed solar energy with perfect efficiency across its entire surface area, the available power would fall short of the observed sublimation rates by at least 2 orders of magnitude. Some mechanism within the nucleus was generating thermal energy at rates that challenged fundamental assumptions about energy conservation in isolated celestial bodies. Attempts to model internal heating mechanisms produced only contradictions and physical impossibilities. Radioactive decay of heavy elements, while theoretically capable of providing internal heat sources, would require isotopic concentrations millions of times higher than observed in any known solar system materials. The short-lived radioisotopes that powered heating in the early solar system had long since decayed to negligible levels, while long-lived isotopes like uranium and thorium produced insufficient energy to drive the observed phenomena. Chemical processes, including the crystallization of amorphous ice or the decomposition of clathrate hydrates, might theoretically release stored energy within the nucleus structure. However, laboratory experiments indicated that such processes occurred slowly over geological timescales and could not sustain the rapid energy release rates observed in 3I Atlas. The comet's behavior suggested energy production mechanisms that operated outside the boundaries of known cometary physics. The most exotic theoretical explanation involved tidal heating caused by gravitational interactions with massive but unseen objects in the outer solar system. Some astronomers proposed that 3I Atlas might be experiencing periodic gravitational stress from a hypothetical planet X or brown dwarf companion, flexing the nucleus structure and generating internal friction similar to the processes that heat Jupiter's moon, Io. However, the orbital stability of known Kuiper belt objects provided no evidence for such massive perturbing bodies, and the energy requirements still exceeded what tidal forces could realistically provide. As the sublimation continued week after week, astronomers began to acknowledge that they were observing phenomena that transcended current understanding of cometary science. The systematic nature of the activity, with its geometric patterns and rhythmic variations, suggested processes more complex than random heating or chaotic outgassing. Something within 3I Atlas appeared to be orchestrating the sublimation according to principles that remained completely opaque to human observation and theory. Only took decades of space missions and laboratory experiments to understand the precise physics of ice sublimation in vacuum conditions. Only took careful thermal modeling to establish the temperature thresholds required for different phases of cometary activity. Only took one impossible comet to demonstrate that the universe still contained processes that operated according to rules humanity had yet to discover or even imagine. The sublimation continues as 3I Atlas moves through its ancient orbit, each molecule of water vapor that escapes into space carrying with it evidence of energy sources that should not exist within a frozen ball of primordial ice. The comet has become a laboratory for impossible physics, challenging scientists to expand their understanding of how matter and energy interact in the cold depths of interplanetary space. The fundamental principle governing cometary tail formation had remained unchanged since Johannes Kepler first observed that comet tails always point away from the sun, regardless of the comet's direction of travel. This phenomenon results from the solar wind, that constant stream of charged particles flowing outward from our star at speeds exceeding 400 kilometers per second, which sweeps gases and dust particles away from the cometary nucleus in the anti-solar direction. For more than 4 centuries, this relationship between solar wind pressure and tail orientation had proven as reliable as any law of physics, observed consistently in thousands of cometary apparitions without a single documented exception. Yet on the morning of April 3rd, automated imaging systems detected something that violated this most basic principle of cometary physics. Comet 3I Atlas had developed not one tail, but 2 distinctly separate structures extending from its nucleus in opposite directions. The primary tail followed conventional physics, streaming away from the sun as expected, composed of ionized gases that glowed with characteristic blue-green fluorescence as solar ultraviolet radiation excited their molecular structures, but extending in the opposite direction, toward the sun rather than away from it. A second tail had materialized like a cosmic impossibility made manifest. This anti-tail, as astronomers immediately dubbed it, displayed properties that challenged every model of solar wind interaction developed over decades of space physics research. Rather than the wispy, translucent appearance typical of normal cometary tails, the anti-tail appeared dense and highly structured, composed of materials that seemed to resist rather than yield to solar wind pressure. Spectroscopic analysis revealed emission lines from heavy metals, iron, nickel, and even trace amounts of gold and platinum elements that should not exist in significant quantities within any cometary nucleus. The anti-tail's behavior defied the inverse square law that governs solar wind intensity. As 3I Atlas moved closer to the Sun over successive weeks, normal physics predicted that solar wind pressure should increase dramatically, making any anti-solar directed tail increasingly impossible to sustain. Instead, the anomalous structure grew stronger and more pronounced, extending across nearly 500,000 kilometers of space in a direction that required it to push directly against the solar wind like a cosmic salmon swimming upstream. High-resolution imaging revealed internal structure within the anti-tail that resembled braided magnetic field lines or twisted plasma filaments. These helical formations rotated slowly around the tail's central axis, completing one revolution approximately every 14 hours, remarkably close to 3I Atlas's own rotation period. The synchronization suggested some form of coupling between the nucleus and the anti-tail that operated through mechanisms unknown to conventional plasma physics. Magnetic field measurements conducted by deep space monitoring stations detected powerful field distortions in the vicinity of the comet, with magnetic flux densities approaching values typically observed only in the immediate vicinity of active stellar coronae. These fields displayed complex geometries that seemed to channel and direct the flow of charged particles in patterns that contradicted standard magnetohydrodynamic theory. The anti-tail appeared to exist within a magnetic bubble or cavity that isolated it from normal solar wind interactions. The most disturbing aspect of the anti-tail's behavior involved its apparent ability to accelerate particles toward the Sun rather than away from it. Doppler shift measurements of spectral lines within the structure indicated velocities approaching 200 kilometers per second in the solar direction speeds that would require enormous energy input to achieve against the pressure of outflowing solar wind. No known mechanism could account for such systematic acceleration of heavy atomic species in directions opposite to all known forces operating in interplanetary space. Theoretical physicists proposed increasingly exotic explanations to account for the anti-tail's existence. Some suggested that 3I Atlas might be generating its own localized gravitational anomalies, creating regions of curved space-time that redirected particle trajectories in impossible directions. Others hypothesized the involvement of dark matter interactions or quantum vacuum effects that might produce repulsive forces under specific conditions. Each proposed mechanism required extensions to established physics that seemed more fantastical than the phenomena they attempted to explain. The International Space Agency convened emergency meetings to assess whether existing spacecraft in the outer solar system could be redirected to conduct closer observations of 3I Atlas. The Voyager probes, still functioning after decades in interstellar space, were too distant and moving in the wrong directions to provide useful data. The New Horizons spacecraft, having completed its Pluto flyby, remained the only human-made object positioned to potentially intercept the comet's trajectory. But even the most optimistic calculations indicated it would miss 3I Atlas by several astronomical units. Ground-based observations continued to document the anti-tail's evolution as 3I Atlas proceeded along its orbit. The structure displayed day-to-day variations that seemed to respond to changes in solar wind conditions, growing more intense during periods of high solar activity and sometimes fragmenting into multiple parallel streams during particularly violent space weather events. These correlations suggested that whatever mechanism created the anti-tail remained coupled to solar wind dynamics, even as it defied the fundamental physics of solar wind interaction. The anti-tail's composition presented additional mysteries that deepened with each spectroscopic observation. Beyond the unexpected heavy metals, astronomers detected emission lines from isotopes that should not exist in nature, radioactive species with half-lives measured in hours or days that required ongoing nuclear processes to maintain their observed abundances. The presence of these short-lived isotopes implied active nuclear reactions occurring within the comet's nucleus, or the anti-tail structure itself. Only took 4 centuries of cometary observation to establish the universal law that tails point away from the sun. Only took 1 morning of automated imaging to document a tail that pointed directly toward our star instead. Only took a few weeks of detailed analysis to confirm that 3I Atlas had entered a regime of physics where fundamental forces operated according to rules that remained completely opaque to human understanding. The anti-tail continues to strengthen as the comet moves through space, each day revealing new layers of impossible behavior that challenge the most basic assumptions about how matter and energy interact in the solar wind environment. Something within or around 3I Atlas has learned to reverse the direction of cosmic forces, creating structures that flow upstream against the fundamental currents of interplanetary space. The spectroscopic analysis of comet 3I Atlas had begun as a routine investigation, following standard protocols developed over decades of cometary observation. Astronomers expected to detect the familiar emission lines of water vapor, carbon monoxide, and simple organic compounds, the typical signatures of sublimating cometary ices that had been catalogued in hundreds of previous observations. These spectral fingerprints serve as cosmic DNA, revealing the precise chemical composition of materials ejected from the nucleus and allowing scientists to trace the primordial chemistry preserved within these ancient frozen archives. Instead, the spectrograph data revealed emission lines that corresponded to no known cometary materials. Among the familiar signatures of water and carbon dioxide, dozens of unidentified spectral features appeared with intensities that suggested abundant concentrations of completely unknown substances. The wavelengths of these mystery lines fell within well-mapped regions of the electromagnetic spectrum, yet they matched no transitions recorded in atomic or molecular databases compiled over more than a century of laboratory spectroscopy. Dr. Sarah Chen, analyzing the data at the European Southern Observatory, initially assumed the unidentified lines represented instrumental artifacts or contamination from terrestrial atmospheric absorption. Comets simply did not contain materials that produced spectral signatures outside the established catalogues of molecular transitions. Every known comet displayed variations on the same basic theme: water ice mixed with carbon-bearing compounds and trace amounts of silicate dust, all formed under the temperature and pressure conditions that prevailed in the outer solar nebula billions of years ago. Yet repeated observations confirmed the reality of the anomalous spectral features, night after night. The mysterious emission lines appeared with consistent wavelengths and intensities that varied in correlation with the comet's rotation period and outgassing activity. The unknown materials were definitely originating from 3I Atlas itself, not from any external source or instrumental effect. Something within the comet's nucleus was producing atomic or molecular transitions that had never been observed in any terrestrial laboratory or astronomical object. The mystery deepened when high-resolution spectroscopy revealed fine structure within the unidentified lines, indicating complex energy level systems that suggested highly organized atomic arrangements. These spectral patterns resembled the signatures of crystalline materials with precisely defined lattice structures. Yet the specific geometries implied by the observed transitions matched no known crystal systems. The materials producing these signals appeared to possess atomic arrangements that operated according to principles outside established solid-state physics. Even more puzzling were the emission lines corresponding to elements that occupied impossible positions on the periodic table. Several strong features indicated atomic transitions characteristic of superheavy elements with atomic numbers exceeding 120, far beyond the range of stable nuclei predicted by current nuclear physics models. These island of stability elements, if they existed at all, should decay within microseconds under normal conditions. Yet their spectral signatures remained constant over weeks of observation. The isotopic ratios revealed by careful spectroscopic analysis provided additional evidence that 3I Atlas contained materials formed under conditions unlike anywhere else in the known solar system. The relative abundances of different isotopes of common elements, like carbon and oxygen, showed patterns that indicated formation temperatures exceeding several thousand degrees Celsius, impossibly hot conditions for materials that should have condensed in the cold outer regions of the primordial solar nebula. Attempts to synthesize the observed spectral patterns in laboratory conditions produced only failures and contradictions. When researchers tried to recreate the pressure and temperature conditions that might produce similar emission lines, the resulting spectra bore no resemblance to the features observed in 3I Atlas. The comet appeared to contain forms of matter that could not be duplicated using any known chemical or physical processes, as if the materials themselves operated according to different fundamental rules. The most extraordinary spectral features appeared in the far ultraviolet and soft X-ray regions of the electromagnetic spectrum, wavelengths that required specialized space-based instruments to observe. These high-energy emissions suggested the presence of materials with electronic structures unlike any known atoms or molecules, displaying energy-level spacings that implied entirely novel forms of chemical bonding. The observed transitions occurred at frequencies that would require electron-binding energies orders of magnitude higher than predicted by standard atomic theory. Quantum mechanical calculations attempting to model the observed spectral patterns consistently failed to reproduce the experimental data. The energy levels implied by the emission lines could not be reconciled with solutions to the Schrödinger equation for any known atomic or molecular systems. Either the fundamental equations of quantum mechanics required modification, or 3I Atlas contained materials that existed in states of matter not previously encountered in the observable universe. The temporal variations in spectral line intensities revealed additional mysteries about the nature of these exotic materials. Some emission lines pulsed with regular periodicities that seemed synchronized to the comet's rotation, while others displayed quasi-random fluctuations that suggested dynamic processes occurring within the nucleus structure. The spectral behavior implied active chemical or nuclear reactions involving the unknown materials, processes that continued despite the extreme cold and vacuum conditions of interplanetary space. International collaborations formed spontaneously as observatories around the world redirected their most sensitive instruments toward 3I Atlas, attempting to map the complete spectral inventory of the comet's anomalous emissions. Each new observation revealed additional unidentified features, expanding the catalog of impossible materials apparently contained within the nucleus. The comet had become a cosmic laboratory displaying forms of matter that challenged the periodic table itself. Only took more than a century of laboratory spectroscopy to catalog the emission lines of every known element and compound. Only took decades of cometary observation to establish the standard composition of these primordial ice balls. Only took one impossible comet to reveal that the universe might contain forms of matter that operated according to physical principles humanity had never encountered or imagined. The spectral lines continue to shine from 3I Atlas as it moves through space, each photon carrying information about atomic and molecular processes that transcend current understanding of chemistry and physics. The comet has become a beacon, transmitting signals from states of matter that may require entirely new theories to comprehend, challenging scientists to expand their conception of what kinds of materials can exist within the cold depths of cosmic space. The orbital trajectory of Comet 3I Atlas had been calculated with the precision that modern astronomy reserves for its most critical predictions. Using gravitational models that incorporated the influence of every known massive body in the solar system, from the Sun's dominant pull to the subtle perturbations caused by distant Kuiper belt objects, astronomers had mapped the comet's path through space with mathematical certainty. The equations of celestial mechanics, refined over centuries of observation and verified by countless successful predictions, indicated exactly where 3I Atlas should appear in Earth's sky at any given moment, accurate to within a few arc-seconds across spans of years or decades. These calculations represented more than mere academic exercise. They embodied humanity's deepest understanding of how gravity shapes the architecture of cosmic motion. Newton's inverse square law, Einstein's corrections for relativistic effects, and the complex multibody interactions that govern solar system dynamics all contributed to orbital predictions that had never failed when applied to well-observed objects. Comet Halley returns precisely on schedule every 76 years. Asteroid trajectories follow predicted paths with clockwork regularity, and space missions navigate to distant worlds using the same mathematical principles that determined 3I Atlas's expected position. Yet on the night of May 7th, positional measurements revealed that 3I Atlas was not where it should have been. The deviation appeared small, initially less than 1 arc-minute from its predicted location, but represented a spatial displacement of nearly 50,000 kilometers at the comet's distance from Earth. Such discrepancies fell well outside the margins of observational error, indicating that the comet had somehow deviated from its calculated trajectory by distances equivalent to 4 Earth diameters. Successive observations confirm that the orbital anomaly was not merely a temporary perturbation, but an ongoing acceleration that continued to accumulate over time. Each night, 3I Atlas appeared slightly further ahead in its orbit than gravitational models predicted, as if some unseen force were continuously adding energy to its motion through space. The effect appeared most pronounced along the comet's direction of travel, suggesting acceleration rather than deflection, with velocity increases measuring several meters per second above the expected orbital speed. The magnitude of this acceleration far exceeded what any known non-gravitational forces could produce. Cometary outgassing, which creates small rocket-like effects as sublimating materials jet away from the nucleus, typically generates accelerations measured in fractions of millimeters per second squared. The Yarkovsky effect, caused by asymmetric thermal radiation from rotating objects, produces even smaller perturbations. Yet 3A Atlas was accelerating at rates approaching several centimeters per second, squared nearly 100 times larger than conventional cometary physics could explain. Detailed analysis of the acceleration pattern revealed systematic variations that correlated with the comet's rotation period and the intensity of its anomalous outgassing activity. During periods when the mysterious spectral emissions reached peak intensity, the orbital acceleration increased correspondingly, suggesting that whatever process was producing the impossible spectroscopy was also responsible for the trajectory modifications. The comet appeared to be converting its exotic internal activity directly into kinetic energy, somehow extracting momentum from processes that violated conservation principles. Gravitational surveys of the surrounding space revealed no massive objects that could account for the observed orbital changes. The region through which 3I Atlas was traveling remained empty of asteroids, planetary bodies, or other gravitational sources capable of producing significant perturbations. Dark matter concentrations, while theoretically possible, would require densities millions of times higher than cosmological models predicted for the outer solar system. The acceleration appeared to originate from within the comet itself, rather than from any external influence. Attempts to model the acceleration using modified gravitational theories produced only marginal success. Some physicists proposed that 3I Atlas might be experiencing effects predicted by alternative theories of gravity, such as modified Newtonian dynamics or emergent gravity models that become significant at extremely low acceleration regimes. However, the scales involved in the comet's motion remained well within the domain where Newtonian gravity had been tested and confirmed to extraordinary precision by centuries of astronomical observation. The most exotic theoretical explanations involve the possibility that 3I Atlas was somehow accessing vacuum energy or zero-point fluctuations of spacetime itself. Quantum field theory predicted that empty space contained enormous amounts of virtual energy that might theoretically be extracted under specific conditions, providing propulsive effects that would appear to violate conservation laws when viewed from classical perspectives. However, no known mechanism could explain how a cometary nucleus might tap into these quantum vacuum effects. The temporal evolution of the acceleration revealed additional puzzling characteristics that deepened the mystery rather than resolving it, rather than remaining constant or following predictable patterns. The magnitude and direction of the orbital perturbations displayed quasi-periodic variations that seemed to respond to external conditions in the solar wind environment during periods of high solar activity, when charged particle fluxes from the Sun increased dramatically. 3IR Atlas's acceleration often intensified correspondingly, as if the comet was somehow harnessing energy from the interplanetary magnetic field. Navigation engineers calculated that if the observed acceleration continued unchanged, 3I Atlas would eventually escape the solar system entirely, achieving velocities sufficient to overcome the Sun's gravitational binding. This scenario would transform the comet from a bound periodic object into an interstellar wanderer, carrying its cargo of impossible physics beyond the reach of human observation. The prospect of losing this unique laboratory for exotic phenomena added urgency to efforts to understand the mechanisms driving its anomalous behavior. Radio telescopes detected additional evidence of the comet's altered motion in the form of Doppler-shifted emissions from its nucleus. The frequency changes in spectral lines provided direct measurements of 3I Atlas's velocity along the line of sight to Earth, confirming the orbital acceleration measurements obtained through positional astronomy. The radio data revealed that the velocity changes occurred in discrete pulses rather than continuous acceleration, suggesting that the propulsive mechanism operated in cycles synchronized to some internal rhythm within the comet's exotic physics. Only took centuries of precise astronomical measurement to establish orbital mechanics as one of physics' most reliable predictive sciences. Only took decades of space exploration to verify gravitational theories across the entire solar system with extraordinary accuracy. Only took one impossible comet to demonstrate that the universe might still contain propulsive mechanisms that operated outside the boundaries of known physics, transforming the predictable clockwork of celestial motion into a puzzle that challenged fundamental assumptions about momentum, energy, and the nature of space itself. The acceleration continues as 3I Atlas moves through its increasingly unpredictable orbit, each day carrying the comet further from its calculated trajectory and deeper into regimes of motion that transcend current understanding of how objects move through the gravitational landscape of interplanetary space. The radio spectrum beyond the orbit of Neptune typically contains only the faintest whispers of cosmic background radiation and the occasional burst from distant pulsars or galactic phenomena. In this realm of profound electromagnetic silence, where the solar wind's charged particles create minimal radio interference and terrestrial broadcasts fade to insignificant murmurs, Sensitive radio telescopes can detect the subtlest emissions from astronomical objects across vast distances. This pristine radio environment makes the outer solar system ideal for detecting weak signals that would be overwhelmed by noise sources closer to the Sun and Earth. When the Arecibo Observatory's successor arrays first detected structured radio emissions originating from the position of Comet 3I Atlas, astronomers initially dismissed the signals as terrestrial interference or perhaps echoes from one of humanity's deep space communication networks. Comets simply do not produce radio waves beyond the occasional plasma emissions associated with interactions between their ionized comas and solar wind magnetic fields. These natural radio sources generate only broad-spectrum noise or simple cyclotron radiation, never the complex, organized patterns that were emerging from 3I Atlas with increasing clarity and intensity. The signals displayed characteristics that immediately distinguished them from any known astronomical radio source. Rather than the random fluctuations typical of natural plasma processes, the emissions followed precisely structured patterns with periodicities that matched the comet's 18-hour rotation period. Within each rotational cycle, the radio bursts organize themselves into sequences of varying duration and intensity, creating what could only be described as a form of cosmic Morse code transmitted from the frozen nucleus of an ancient ball of ice and dust. Dr. James Morrison, leading the radio astronomy team at the Green Bank Observatory, spent weeks verifying that the signals originated from 3I Atlas rather than from any terrestrial or known astronomical source. Triangulation measurements using multiple radio telescopes confirmed that the emissions came specifically from the comet's nucleus, with source positions accurate to within the resolution limits of very long baseline interferometry. The signals displayed the expected Doppler shifts corresponding to the comet's orbital motion, definitively establishing their extraterrestrial origin. The frequency characteristics of the radio emissions revealed additional layers of mystery that defied conventional plasma physics. The signals appeared simultaneously across multiple discrete frequency bands, with each band carrying apparently independent information patterns. The primary emissions occurred at 1420 MHz, the famous hydrogen line frequency used by radio astronomers for mapping interstellar gas, but subsidiary signals appeared at harmonics and subharmonics that created complex interference patterns when analyzed together. Most disturbing was the temporal structure within individual radio bursts, which displayed modulation patterns reminiscent of digital communication protocols. Each burst contained rapid variations in amplitude and phase that encoded what appeared to be binary information, with transition rates approaching several thousand bits per second. The sophistication of these modulation schemes exceeded the complexity of most terrestrial radio communications, suggesting information processing capabilities that seemed impossible within a cometary nucleus composed primarily of frozen water and organic compounds. Attempts to decode the apparent information content of the signals produced frustrating results that hinted at underlying organization without revealing comprehensible meaning. Statistical analysis indicated that the bit patterns contained far more structure than random noise, with entropy levels and autocorrelation functions characteristic of encoded data rather than natural processes. Yet every attempt to apply standard cryptographic or communication decoding techniques failed to extract recognizable patterns or messages from the seemingly organized emissions. The power requirements for transmitting such strong radio signals across interplanetary distances exceeded the total energy budget available to conventional cometary processes by enormous margins. Broadcasting at the observed intensity levels required power generation approaching several megawatts, equivalent to the output of a small nuclear reactor, yet 3I Atlas showed no thermal signatures or other evidence of energy production mechanisms capable of sustaining such prodigious radio transmission. The comet appeared to be violating conservation of energy as blatantly as it violated orbital mechanics and spectroscopic physics. Radio polarization measurements revealed that the emissions possessed complex circular and linear polarization characteristics that varied systematically throughout each transmission cycle. These polarization patterns suggested that the radio waves were being generated and shaped by magnetic fields with geometries unlike anything observed in natural astrophysical environments. The field configurations implied by the polarization data required magnetic flux densities approaching those found in stellar coronat, yet generated within the interior of an object barely 12 kilometers in diameter. Deep space monitoring networks designed to track spacecraft communications and detect potential signals from extraterrestrial intelligence began focusing their most sensitive instruments on 3I Atlas. The Search for Extraterrestrial Intelligence Institute classified the emissions as the strongest candidate signal ever detected, displaying characteristics that seem to indicate artificial origin while simultaneously emerging from an object that should contain no technology or organized systems capable of radio transmission. The radio signals displayed time-variable characteristics that correlated with other anomalous behaviors exhibited by the comet. During periods of intense spectroscopic activity, when the mysterious emission lines reached peak intensity, the radio transmissions increased correspondingly in both power and complexity. The correlation suggested that all of 3I Atlas's impossible phenomena arose from related physical processes, as if some central organizing principle within the nucleus coordinated the various anomalous activities. International radio astronomy organizations established continuous monitoring protocols to maintain round-the-clock observation of the signals as 3I Atlas continued along its altered orbital trajectory. The emissions showed gradual evolution over timescales of days and weeks, with new frequency components appearing while others faded away, creating an ever-changing symphony of structured radio noise that seemed to respond to external conditions in the solar wind and interplanetary magnetic field environment. Only took decades of radio astronomy to map the natural emissions from every known type of cosmic object, from planets to pulsars to distant galaxies. Only took centuries of understanding plasma physics to explain how charged particles generate electromagnetic radiation in space environments. Only took one impossible comet to demonstrate that the universe might contain radio sources that operated according to principles completely outside established electromagnetic theory, broadcasting structured signals that suggested information processing capabilities within frozen balls of primordial ice. The radio whispers continue to flow from 3I Atlas as it moves through space, each transmission cycle adding new layers of organized complexity to signals that challenge fundamental assumptions about what kinds of physical processes can generate structured electromagnetic emissions in the cold vacuum of the outer solar system. For more than 3 centuries, astronomers had maintained a clear and consistent understanding of cometary nuclei as irregular, potato-shaped objects composed of loosely consolidated ice and dust. These dirty snowballs, as Fred Whipple famously described them, possessed the chaotic, bumpy surfaces typical of objects formed through gravitational accretion in the cold outer regions of the primordial solar nebula. High-resolution images from spacecraft missions to comets like Halley, Wild 2 and Churyumov-Gerasimenko had consistently revealed landscapes of gentle hills, impact craters, and dust-covered plains, surfaces sculpted by billions of years of micrometeorite bombardment and thermal cycling, but fundamentally random in their topographical organization. The first detailed images of 3I Atlas's nucleus, captured by the Hubble Space Telescope's advanced imaging systems during a brief period of exceptional atmospheric stability, revealed something that challenged every assumption about cometary structure and formation. Instead of the expected irregular outline of a cosmic rubble pile, the nucleus displayed geometric properties that seemed almost crystalline in their precision. Sharp edges intersected at angles that approximated regular polyhedra, creating surface features that appeared designed rather than randomly accumulated over geological time. Dr. Maria Santos, analyzing the morphological data at the Space Telescope Science Institute, initially assumed the geometric features represented imaging artifacts, or perhaps unusual lighting conditions that created optical illusions of regularity. Cometary nuclei simply did not possess the internal organization required to maintain geometric shapes against the relentless erosion of space weathering and thermal stress. The chaotic accretion processes that formed these objects during the solar system's youth should have produced thoroughly irregular structures, not the systematic arrangements of planes and vertices that appeared in the Atlas images. Yet successive observations confirmed the reality of the nucleus's anomalous geometry. Adaptive optics systems at ground-based observatories resolved surface details that revealed not merely approximate geometric regularity, but mathematical precision approaching the tolerances of engineered structures. The nucleus displayed faceted surfaces that intersected along edges defined to within measurement uncertainties, creating a 12-sided polyhedron that resembled a cosmic dodecahedron carved from primordial ice with impossible accuracy. The geometric organization extended beyond simple external morphology into the detailed topography of individual surface features. Impact craters, which should have appeared as random circular depressions scattered across the nucleus, instead organized themselves into patterns that suggested underlying structural control. The largest craters occupied positions that corresponded to the vertices of the dodecahedral geometry, while smaller impacts aligned along the edges and face centers with statistical precision that exceeded any reasonable explanation based on random bombardment processes. Thermal infrared imaging revealed that the geometric surface features corresponded to variations in internal heat distribution that followed the same mathematical organization. The edges of the dodecahedral faces appeared slightly warmer than the central regions, creating temperature patterns that mapped precisely onto the visible geometric structure. This correlation suggested that the nucleus's internal architecture possessed the same geometric organization as its external morphology, with heat flow channels or material boundaries that followed crystallographic principles scaled up to planetary dimensions. The implications of such systematic internal organization challenged fundamental theories of cometary formation and evolution. The standard accretion models predicted that comets form through the gentle gravitational collapse of dust and ice particles in the outer solar nebula, creating loosely bound structures with random internal organization and irregular shapes determined by chaotic collision processes. The systematic geometry observed in 3I Atlas implied formation mechanisms that operated according to principles of structural optimization rather than random accumulation. Attempts to model the stress distributions within a dodecahedral nucleus produced results that seemed to explain the object's remarkable structural stability. Unlike irregular cometary shapes, which concentrate mechanical stress at random points and create zones of weakness that lead to fragmentation, the geometric organization of 3I Atlas distributed stresses uniformly throughout its volume. The dodecahedral configuration represented a form of structural engineering that maximized strength-to-weight ratios while minimizing internal stress concentrations. The surface composition analysis revealed additional evidence of systematic organization that extended to the molecular level, rather than the random mixture of ices and organic compounds typical of cometary surfaces. 3I Atlas displayed distinct compositional zones that corresponded precisely to its geometric structure. Each dodecahedral face possessed a unique spectroscopic signature, suggesting that different chemical compositions had been segregated during formation according to the same organizing principles that determined the nucleus's overall geometry. Most remarkably, the geometric features appeared to be actively maintained against the erosive effects that should have degraded any regular structures over billions of years of exposure to cosmic radiation and micrometeorite bombardment. The edges and vertices of the dodecahedral form showed no evidence of the rounding or wear that should have accumulated during the comet's long residence in the outer solar system. Instead, the geometric precision seemed to be constantly renewed by some process that actively restored and maintained the mathematical perfection of the nucleus's form. High-resolution mapping of surface features revealed additional levels of geometric organization that cascaded down through multiple scales of structural hierarchy. Within each dodecahedral face, smaller scale features organize themselves into hexagonal and pentagonal patterns that created fractal-like arrangements of geometric complexity. These nested structures suggested that the same organizing principles operated across spatial scales ranging from meters to kilometers, creating a form of architectural organization that spanned multiple orders of magnitude. The rotational dynamics of 3I Atlas provided further evidence of its unusual internal structure. While irregular cometary nuclei typically wobble and precess as they rotate due to asymmetric mass distributions, the dodecahedral nucleus spun with the stability of a precisely balanced gyroscope. The rotational axis remained fixed in space with an accuracy that exceeded the measurement precision of astronomical instruments, indicating internal mass distributions that achieved perfect rotational balance despite the complex geometric organization. Gravitational field mapping, using radio tracking of the comet's orbital perturbations, revealed mass distributions that corresponded exactly to the geometric surface features. The gravitational signature indicated that the internal density variations followed the same dodecahedral organization as the external morphology, with denser materials concentrated along the geometric edges and vertices. This systematic mass distribution suggested internal structures that had been organized according to principles of geometric optimization rather than random accretional processes. Only took centuries of cometary observation to establish the chaotic, irregular nature of these primordial remnants. Only took decades of spacecraft missions to confirm that comet nuclei represented loosely consolidated rubble piles shaped by random accretion and erosion processes. Only took one impossible nucleus to reveal that the universe might contain objects that displayed architectural organization rivaling the most sophisticated human engineering, carved from ice and stone according to geometric principles that transcended current understanding of how natural structures form and maintain themselves over cosmic timescales. The geometric precision continues to manifest as 3I Atlas rotates through space, each revolution revealing new details of mathematical organization that challenge fundamental assumptions about the chaotic nature of small body formation in the outer solar system. The magnetic environment surrounding comet 3I Atlas should have remained as quiescent and predictable as the interplanetary space through which it traveled. At its distance from the Sun, the local magnetic field consisted primarily of the interplanetary magnetic field, those tenuous field lines carried outward by the solar wind at strengths measuring mere nanotesla, barely detectable above the background noise of cosmic magnetic fluctuations. Comets, composed primarily of electrically neutral ice and dust, typically interact only weakly with magnetic fields, producing minor perturbations as their ionized comas encounter the solar wind's embedded magnetism. Yet, magnetometer readings from deep space monitoring stations began detecting powerful magnetic field distortions in the vicinity of 3I Atlas that exceeded the intensity of Earth's magnetic field by factors of hundreds. These anomalous fields appeared to originate directly from the comet's nucleus, creating a localized magnetic environment with flux densities approaching those found in the immediate vicinity of active stellar coronae. The field strength at the nucleus surface measured nearly 100 millatesla, powerful enough to levitate metallic objects and significantly deflect charged particle trajectories across thousands of kilometers of surrounding space. Dr. Elena Kozlova, analyzing the magnetometer data at the Institute for Space Physics in Moscow, initially suspected instrumental malfunction or contamination from unshielded electronics aboard the monitoring spacecraft. Cometary nuclei simply do not generate magnetic fields of such extraordinary intensity. The materials composing these ancient objects, water ice, frozen carbon dioxide, and organic compounds possess no intrinsic magnetism beyond the diamagnetic effects that produce field strengths measured in nanotesla rather than millitesla. The observed magnetic signatures suggested field generation mechanisms that operated far outside the boundaries of known cometary physics. The magnetic field geometry displayed characteristics that challenged fundamental principles of magnetohydrodynamics and electromagnetic field theory. Rather than the dipolar configuration typical of planetary magnetic fields, 3I Atlas generated a complex multipolar structure that seemed to violate basic constraints imposed by Maxwell's equations. The field lines formed closed loops that appeared to terminate and originate within the nucleus itself, creating magnetic monopole-like configurations that should not exist according to established electromagnetic theory. Most remarkably, the magnetic field appeared to be actively reshaping the structure of surrounding space-time, creating gravitational lens effects that slightly distorted the positions of background stars when viewed through the comet's magnetic envelope. These distortions suggested that the intense magnetic fields were somehow coupling to the gravitational field in ways predicted only by the most exotic unified field theories, theoretical frameworks that remained highly speculative and had never been observed under natural conditions. The temporal variations in magnetic field strength revealed systematic patterns that correlated with the comet's other anomalous behaviors. During periods of intense spectroscopic activity and radio transmission, the magnetic field strength increased correspondingly, suggesting that all of 3I Atlas's impossible phenomena arose from related electromagnetic processes within the nucleus. The magnetic pulsations followed complex rhythms that seemed to respond to external conditions in the solar wind, as if the comet's magnetic system was somehow drawing energy from the interplanetary electromagnetic environment. Charged particle detectors throughout the outer solar system registered the magnetic field's dramatic effects on the local space plasma environment. The intense magnetic forces deflected solar wind protons and electrons in trajectories that created shock waves and standing plasma formations extending millions of kilometers from the comet's position. These magnetic disturbances propagated outward at velocities approaching the speed of light, creating electromagnetic pulse effects that briefly interfered with deep space communication systems across the entire outer solar system. The magnetic field's influence on the comet's own structure became apparent through careful observation of the nucleus rotation and surface activity patterns. The geometric surface features appeared to be magnetically coupled to the field lines, with material ejection occurring preferentially along directions that aligned with magnetic flux concentrations. This coupling suggested that the nucleus itself possessed magnetic properties that allowed it to interact directly with its own generated field, creating a form of magnetic self-organization unlike anything observed in natural astronomical objects. Attempts to model the magnetic field generation mechanisms using conventional theories of magnetism produced only contradictions and impossibilities. The field strengths observed around 3I Atlas required current densities that would instantly vaporize any known materials through resistive heating. Yet the nucleus showed no thermal signatures corresponding to such enormous electromagnetic energy dissipation. The magnetic field appeared to be generated through processes that operated without the energy losses predicted by classical electromagnetic theory. The most exotic theoretical explanations involve the possibility that 3U Atlas contained exotic forms of matter that displayed magnetic properties unknown to terrestrial physics. Some physicists proposed that the nucleus might contain magnetic monopoles, hypothetical particles predicted by certain grand unified theories, but never observed in nature. Others suggested the involvement of superconducting materials that could sustain enormous current densities without resistance, though the temperatures required for conventional superconductivity remained far below the thermal environment within any cometary nucleus. Magnetic field mapping revealed that the anomalous magnetism extended well beyond the visible nucleus into regions that should have contained only vacuum and trace amounts of sublimated cometary material. The field strength decreased with distance according to power laws that differed significantly from the inverse cube relationship expected for conventional magnetic dipoles, suggesting field generation mechanisms that operated through non-local effects or the involvement of additional spatial dimensions beyond the familiar three. The magnetic field's interaction with the solar wind created standing wave patterns in the surrounding plasma that resembled the bow shock formations found around magnetized planets, but with geometric characteristics that seemed to follow the same dodecahedral symmetry as the nucleus surface. These plasma structures rotated in synchronization with the comet's 18-hour spin period, maintaining their geometric organization despite the turbulent dynamics of supersonic plasma flow around magnetic obstacles. Radio telescope observations detected synchrotron radiation emanating from the comet's magnetic environment, electromagnetic emissions produced when charged particles spiral along magnetic field lines at relativistic velocities. The synchrotron spectrum indicated particle energies approaching those found in the most energetic cosmic ray sources, yet generated within the magnetic field of an object barely 12 kilometers in diameter. The acceleration mechanisms required to produce such high-energy particles remained completely mysterious within the context of cometary physics. Only took centuries of studying planetary magnetism to understand how magnetic fields are generated by dynamo processes in molten metallic cores. Only took decades of space exploration to map the magnetic environments around every known type of solar system object. Only took one impossible comet to demonstrate that the universe might contain magnetic field generation mechanisms that operated according to principles completely outside established electromagnetic theory, creating localized regions of curved spacetime where magnetic forces achieved intensities that challenged the fundamental structure of physical reality itself. The magnetic field continues to pulse and fluctuate as 3I Atlas moves through space, each variation revealing new aspects of electromagnetic organization that transcend current understanding of how magnetic forces can arise from and influence the behavior of matter in the cold vacuum of interplanetary space. The thermal profile of Comet 3I Atlas should have displayed the uniform cooling characteristic of an inert object heated only by distant solar radiation. At its current distance from the Sun, thermal equilibrium calculations predicted surface temperatures locked at approximately -235 degrees Celsius, with only minor variations caused by the comet's rotation and the different thermal properties of surface materials. The nucleus should have resembled a cosmic ice cube, slowly radiating away the minimal thermal energy it received from starlight and solar photons, maintaining the primordial cold that had preserved its ancient chemical composition for billions of years. Instead, Thermal infrared observations revealed surface temperature patterns that defied every model of passive heating and cooling in space environments. Distinct regions of the dodecahedral nucleus displayed temperatures approaching -100 degrees Celsius, nearly 150 degrees warmer than solar heating could possibly provide at such extreme distances from the Sun. These thermal anomalies were not randomly distributed across the surface, but followed the same geometric organization as the nucleus's crystalline architecture, creating patterns of warmth that mapped precisely onto the edges and vertices of the dodecahedral structure. Dr. Rebecca Thompson, analyzing the thermal data at the Jet Propulsion Laboratory's Cometary Science Division, initially attributed the temperature variations to measurement errors or perhaps unusual thermal conductivity properties of the nucleus materials. The observed heat signatures exceeded the total solar energy flux available at 3I Atlas's orbital position by factors approaching 1,000, suggesting internal heat generation mechanisms that operated far beyond the scope of any known cometary processes. Yet repeated observations confirmed the reality of the systematic warming patterns and their correlation with the nucleus's impossible geometric organization. The thermal anomalies displayed time-variable characteristics that synchronized with the comet's 18-hour rotation period, but not in the manner expected from objects heated by external radiation sources. Rather than following the predictable day-night temperature cycles typical of rotating bodies in space, the warm regions pulsed with rhythmic intensity variations that seemed to originate from within the nucleus itself. During each rotational cycle, the temperature patterns would strengthen and fade according to internal schedules that appeared completely independent of solar illumination angles or thermal inertia effects. High-resolution thermal mapping revealed that the heat distribution followed fractal patterns that cascaded down through multiple scales of spatial organization. Within each warm dodecahedral face, smaller-scale thermal features arranged themselves into hexagonal and pentagonal geometries that mirrored the larger structural organization. These nested heat patterns suggested thermal generation mechanisms that operated simultaneously across spatial scales ranging from meters to kilometers, creating hierarchical arrangements of warming that violated standard models of heat conduction and radiation. The spectral characteristics of the thermal emissions provided additional evidence that the heating mechanisms operated through processes unknown to conventional thermodynamics. The infrared radiation emanating from the warm regions displayed spectral signatures that differed significantly from blackbody radiation expected from objects at the observed temperatures. Instead of smooth thermal continua, the spectra contained discrete emission lines that suggested highly organized atomic and molecular processes within the heated materials. Most remarkably, some regions of the nucleus appeared to be warming from within rather than from any external heat source. Thermal gradient measurements indicated that the hottest temperatures occurred several meters below the surface, with heat flowing outward through the overlying ice and dust layers. This inverted temperature profile contradicted every principle of solar heating and thermal equilibrium, suggesting energy generation mechanisms that operated within the interior structure of the nucleus itself. The total power output required to sustain the observed thermal anomalies exceeded the energy available from any known chemical or nuclear processes by enormous margins. The steady heat generation approached several megawatts, equivalent to a small power plant, yet the nucleus showed no evidence of the fuel consumption or waste product accumulation that should accompany such prodigious energy production. The heating appeared to violate conservation of energy as blatantly as 3I Atlas's other impossible phenomena. Attempts to correlate the thermal patterns with other anomalous behaviors revealed systematic relationships that suggested common underlying mechanisms. During periods of intense radio transmission and spectroscopic activity, the thermal anomalies strengthened correspondingly. with temperature increases that seem to draw energy from the same mysterious processes that powered the comet's electromagnetic emissions. The correlations implied that the nucleus contained integrated systems that coordinated thermal, magnetic, and electromagnetic effects according to principles that remained completely opaque to human understanding. The thermal emissions created their own microenvironment around the nucleus that significantly altered the local sublimation and outgassing processes. Materials that should have remained frozen solid at the prevailing space temperatures began to sublime vigorously in the vicinity of the thermal anomalies, creating complex patterns of gas and dust emission that followed the geometric organization of the heat sources. These localized sublimation zones produced the jets and streamers that gave 3I Atlas its increasingly complex coma structure. Thermodynamic calculations revealed that the heating mechanisms operated with efficiencies that approached theoretical limits imposed by fundamental physical principles. The conversion of whatever energy source powered the thermal anomalies into heat occurred with minimal waste, suggesting optimization processes that exceeded the capabilities of known, natural, or artificial energy systems. The thermal efficiency implied underlying physical processes that operated according to principles of energy conversion not yet discovered by human science. The heating patterns displayed adaptive characteristics that seemed to respond to external conditions in ways that suggested active thermal regulation rather than passive heat generation. During periods of intense solar wind activity, when charged particle fluxes in the comet's vicinity increased dramatically, the thermal anomalies often adjusted their intensity and distribution patterns in apparent response to the changing electromagnetic environment. This adaptive behavior implied sensing and control mechanisms that operated at scales and through processes that remained entirely mysterious. Infrared spectroscopy of the heated regions revealed the presence of molecular species that should not exist at any temperature within a cometary nucleus. Complex organic compounds with high formation energy requirements appeared in the thermal emission spectra, suggesting that the heating processes were not merely warming existing materials, but actively synthesizing new chemical species through mechanisms that operated outside established organic chemistry principles. Only took decades of thermal physics research to understand how objects radiate heat according to their temperature and surface properties. Only took centuries of astronomical observation to establish that solar heating provides the primary thermal energy source for all objects in the solar system. Only took one impossible comet to demonstrate that the universe might contain thermal generation mechanisms that operated independent of external energy sources, creating patterns of warming that followed geometric principles while violating fundamental assumptions about energy conservation and thermodynamic equilibrium. The thermal anomalies continue to pulse and evolve as 3I Atlas moves through space, each temperature variation revealing new aspects of energy generation that transcend current understanding of how heat can be produced and organized within frozen balls of primordial ice and dust suspended in the near absolute zero environment of interplanetary space. The gravitational field surrounding Comet 3I Atlas should have remained as constant and predictable as the nucleus mass that generated it. According to Newton's law of universal gravitation, verified through centuries of astronomical observation and space exploration, the gravitational attraction produced by any object depends solely on its total mass and the distance from its center, fundamental parameters that remain invariant unless material is physically added or removed from the system. For a 12-kilometer nucleus composed of ice and dust, the gravitational field strength should have measured a few thousandths of Earth's surface gravity, creating imperceptible effects on surrounding space except at extremely close distances. Yet precision tracking of nearby asteroids and deep space monitoring stations began detecting gravitational anomalies in the vicinity of 3I Atlas that suggested the comet's mass was fluctuating in ways that violated fundamental principles of mass conservation. Small asteroids following predictable trajectories through the outer solar system experienced subtle orbital perturbations when passing within several million kilometers of the comet's position. Deflections that indicated gravitational forces varying by factors of 10 or more over periods of hours or days. Dr. Harrison Webb. Analyzing orbital dynamics data at the European Space Agency's Mission Operations Center initially attributed the gravitational anomalies to observational errors, or perhaps the gravitational influence of undetected objects in the comet's vicinity. The apparent mass variations implied changes in the nucleus composition or structure that would require the spontaneous creation or annihilation of matter processes that violated some of the most fundamental conservation laws in physics. Yet repeated measurements confirmed that something in the region around 3I Atlas was generating gravitational effects that changed systematically over time. The gravitational fluctuations displayed periodicities that correlated with the comet's rotation and other anomalous behaviors, suggesting that the varying gravitational field arose from the same mysterious processes that powered the thermal anomalies, radio emissions, and impossible spectroscopy. During periods of peak activity, when the nucleus blazed with impossible thermal signatures and transmitted structured radio signals, the gravitational field strength increased correspondingly, as if the comet's effective mass were growing in synchronization with its other exotic phenomena. Most remarkably, the gravitational variations appeared to propagate outward from the nucleus at velocities significantly exceeding the speed of light, creating instantaneous effects on objects separated by distances that should have required minutes or hours for gravitational influences to traverse. These superluminal gravitational effects violated Einstein's general relativity as fundamentally as they violated Newtonian gravity, suggesting modifications to space-time geometry that operated through mechanisms beyond current theoretical frameworks. High-precision gravitational wave detectors, designed to measure the minute space-time distortions produced by colliding black holes and neutron stars, registered anomalous signals originating from the direction of 3I Atlas. These gravitational waves displayed characteristics unlike any previously observed astrophysical sources, with frequencies and amplitude modulations that seemed to encode structured information rather than representing the chaotic collapse or collision processes that typically generate detectable gravitational radiation. The gravitational field geometry around the nucleus appeared to deviate from the spherically symmetric pattern expected from a uniform mass distribution. Instead, the field lines followed complex trajectories that mirrored the dodecahedral symmetry of the nucleus surface, creating regions of enhanced and diminished gravitational attraction that rotated in synchronization with the comet's spin. These asymmetric gravitational effects produced tidal forces that should have been impossible for an object of 3I Atlas's modest size and mass. Attempts to model the variable gravitational field using Einstein's field equations produced solutions that required exotic forms of matter with negative energy densities, theoretical constructs that had never been observed in nature, and whose existence remained highly speculative even within the most advanced theoretical physics frameworks. The gravitational anomalies implied space-time curvature patterns that could only be sustained by materials with properties that transcended the standard model of particle physics. The most disturbing aspect of the gravitational variations involved their apparent ability to create closed, time-like curves in the surrounding space-time geometry. Theoretical calculations based on the observed field patterns suggested that objects following certain trajectories near 3I Atlas might experience temporal paradoxes, arriving at their destinations before they departed or encountering their own past trajectories. These causality violations represented some of the most profound challenges to fundamental physics ever observed in natural phenomena. Deep space communication networks detected interference patterns that correlated with the gravitational anomalies, suggesting that the variable gravitational field somehow influenced electromagnetic propagation in ways not predicted by standard theories of space-time curvature. Radio signals passing through the region around 3I Atlas experienced frequency shifts and timing delays that varied according to the gravitational field fluctuations, indicating coupling between gravitational and electromagnetic effects that exceeded the predictions of general relativity. The gravitational waves emanating from the comet created interference patterns when they encountered the gravitational fields of other solar system objects, producing standing wave formations that temporarily altered the orbital dynamics of asteroids and spacecraft throughout the outer solar system. These gravitational interference effects propagated across astronomical distances at superluminal velocities, creating network-like patterns of space-time distortion that connected 3I Atlas to objects separated by billions of kilometers. Laboratory experiments designed to detect the gravitational influence of small masses began registering anomalous results that seemed to correlate with the activity cycles of 3I Atlas, despite the enormous distance separating terrestrial laboratories from the comet's position. These correlations suggested that the gravitational anomalies possessed non-local characteristics that transcended the inverse square law limitations of conventional gravitational interactions. The mass fluctuations appeared to violate not only conservation of mass energy, but also the equivalence principle that forms the foundation of general relativity. The gravitational acceleration experienced by different materials in the comet's vicinity varied according to their atomic composition rather than remaining identical for all substances as Einstein's theory predicted. These composition-dependent gravitational effects suggested modifications to space-time geometry that operated at fundamental levels of matter and energy. Theoretical physicists proposed increasingly exotic explanations that involving higher dimensional physics, quantum gravity effects, or interactions with parallel universes mechanisms that remained highly speculative and largely untestable under normal conditions. Each proposed explanation required extensions to established physics that seemed as impossible as the phenomena they attempted to describe, creating a cascade of theoretical challenges that threatened to undermine fundamental assumptions about the nature of gravity, space-time, and physical reality itself. Only took centuries of gravitational physics research to establish mass conservation as one of the most fundamental principles governing physical systems. Only took decades of precision spacecraft tracking to verify gravitational theory across the entire solar system with extraordinary accuracy. Only took one impossible comet to demonstrate that the universe might contain gravitational generation mechanisms that operated independent of conventional mass energy sources, creating space-time distortions that challenge the most basic assumptions about how matter curves the fabric of cosmic space and time. The gravitational anomalies continue to ripple outward from 3I Atlas as it moves through space, each fluctuation revealing new aspects of space-time manipulation that transcend current understanding of how gravitational fields can be generated, modified, and propagated through the geometric structure of four-dimensional reality. The acceleration of Comet 3I Atlas had evolved beyond the subtle orbital perturbations first detected months earlier into something that challenged the most fundamental assumptions about motion, momentum, and energy in the cosmos. What began as minor deviations from calculated trajectory differences measurable in meters per second had amplified into systematic velocity increases that exceeded the capabilities of any known propulsion mechanism by orders of magnitude. The comet now moved through space with accelerations approaching several meters per second squared, velocities that would require enormous thrust forces applied continuously over extended periods to achieve through conventional means. The magnitude of this acceleration far surpassed what chemical rockets, ion drives, or even theoretical fusion propulsion systems could sustain without massive fuel consumption and reaction mass ejection. Yet, 3I Atlas showed no evidence of propellant depletion or the characteristic exhaust plumes that should accompany any form of reaction-based propulsion. The comet appeared to be extracting momentum from the quantum vacuum itself, tapping into energy sources that existed within the fundamental structure of space-time, rather than requiring conventional fuel and oxidizer combinations. Dr. Sarah Kim, analyzing the propulsion anomalies at NASA's Breakthrough Propulsion Physics program, calculated that the observed acceleration required power generation approaching several terawatts energy levels comparable to the total electrical output of human civilization applied continuously to accelerate a single 12-kilometer object. The efficiency of momentum transfer exceeded theoretical limits imposed by conservation of momentum and energy, suggesting propulsion mechanisms that operated through principles completely outside established physics. The acceleration vector did not remain constant, but varied systematically according to patterns that seemed to respond to local conditions in the quantum vacuum fluctuations surrounding the comet's trajectory. During periods when theoretical models predicted higher virtual particle densities in the vacuum, 3I Atlas's acceleration increased correspondingly, as if the nucleus contained mechanisms for harvesting zero-point energy and converting these quantum fluctuations directly into kinetic motion through space. Most remarkably, the acceleration appeared to violate Newton's third law, the principle that every action produces an equal and opposite reaction by generating thrust without any observable reaction products or momentum transfer to the surrounding environment. The comet moved faster and faster through space without ejecting mass in the opposite direction, creating momentum changes that seemed to emerge from nowhere rather than being transferred from one system to another according to conservation principles. The propulsion system, whatever its nature, displayed adaptive characteristics that suggested active navigation and course correction capabilities rather than simple continuous acceleration. Small adjustments to the acceleration magnitude and direction occurred in real-time response to gravitational influences from distant planets, as if 3I Atlas possessed autonomous guidance systems that could calculate optimal trajectories and make precision adjustments to maintain desired flight paths through the complex gravitational landscape of the outer solar system. Theoretical analysis of the acceleration patterns revealed correlations with electromagnetic field configurations in the local interstellar medium, suggesting that the propulsion mechanism might be extracting energy from magnetic field interactions or charged particle flows that permeated supposedly empty space. The comet appeared to be sailing on currents of virtual particles and quantum fields that remained invisible to conventional detection methods, but provided limitless energy sources for objects equipped with appropriate conversion technologies. The acceleration effects extended beyond the nucleus itself to influence the motion of gas and dust particles within the comet's expanding coma and tail structures. These materials, which should have followed ballistic trajectories determined solely by their initial ejection velocities and solar wind pressure, instead displayed coordinated motion patterns that suggested they remained coupled to the nucleus propulsion system across distances of thousands of kilometers. The entire comet system moved as an integrated unit despite the tenuous connections between its constituent parts. Quantum field theory calculations suggested that the observed acceleration might result from manipulation of the Casimir effect, the attractive force between closely spaced conducting surfaces that arises from quantum vacuum fluctuations. If the nucleus contained microscopic structures arranged at precisely controlled spacing intervals, these Casimir forces might theoretically be harnessed to extract momentum from the vacuum, creating thrust without reaction mass ejection. However, the engineering precision required to implement such quantum vacuum manipulation exceeded current human technological capabilities by centuries or millennia. The propulsion system displayed characteristics that seemed to violate the second law of thermodynamics by creating organized motion from the random thermal fluctuations of quantum vacuum states. Rather than requiring external energy input to maintain acceleration, the system appeared to decrease local entropy by converting chaotic quantum processes into directed kinetic motion, effectively creating a perpetual motion machine that operated at the fundamental level of physical reality. Navigation analysis revealed that 3I Atlas's altered trajectory would eventually carry it beyond the solar system entirely, transforming the comet from a gravitationally bound periodic object into an interstellar wanderer. The acceleration profile suggested that the nucleus would achieve escape velocity within several years, carrying its cargo of impossible physics beyond the reach of human observation and into the cosmic void where its exotic technologies might remain hidden for millions or billions of years. The acceleration mechanism appeared to draw energy from sources that transcended the conventional distinction between matter and space-time, suggesting unified field effects that coupled gravitational, electromagnetic, and quantum phenomena into integrated propulsion systems. These mechanisms operated according to principles that might represent technologies developed by civilizations with understanding of physics far beyond current human knowledge, or perhaps natural processes that emerged under conditions not yet encountered in terrestrial laboratories. Deep space monitoring networks detected gravitational wave emissions from 3I Atlas that correlated with its acceleration cycles, indicating that the propulsion system generated ripples in space-time itself as it extracted momentum from quantum vacuum fluctuations. These gravitational signatures provided direct evidence that the acceleration mechanism operated through modifications to the fundamental geometry of space and time rather than through conventional interactions between matter and electromagnetic fields. Only took centuries of rocket science development to understand how propulsion systems must eject reaction mass to generate thrust according to Newton's laws of motion. Only took decades of spacecraft engineering to establish the fundamental limitations imposed by fuel requirements and exhaust velocity constraints. Only took one impossible comet to demonstrate that the universe might contain propulsion mechanisms that operated independent of reaction mass and fuel consumption, extracting unlimited energy from the quantum vacuum itself to achieve accelerations that transcended every known principle of momentum conservation and thermodynamic efficiency. The impossible acceleration continues as 3I Atlas moves faster and faster through space, each increment of velocity revealing new aspects of vacuum energy manipulation that challenge fundamental assumptions about the nature of propulsion, momentum, and the quantum mechanical foundations of physical reality itself. The silence that descended upon observatories worldwide on the morning of June 21st arrived without warning, sudden and absolute in its totality. For months, scientists had grown accustomed to the steady stream of impossible data flowing from their instruments as they tracked Comet 3I Atlas through its increasingly anomalous journey across the outer solar system. Radio telescopes had maintained continuous contact with the structured emissions emanating from the nucleus. Spectroscopes had catalogued hundreds of impossible atomic transitions, and thermal imaging systems had mapped the geometric patterns of heat that violated every principle of energy conservation. Then, in a moment that would be remembered as the Great Silence, every instrument simultaneously lost contact with the comet. The failure occurred precisely at 14:32:17 Universal Time, recorded by atomic clocks with nanosecond precision across every observatory on Earth and throughout the solar system. Radio telescopes from Arecibo to Parkes registered the cessation of signals within the same microsecond. Despite the light travel time differences that should have created delays measured in minutes or hours for widely separated observing stations, The simultaneity of the event suggested that whatever had happened to 3I Atlas transcended the normal limitations of electromagnetic propagation, affecting the entire network of human observation systems through mechanisms that operated instantaneously across astronomical distances. Dr. Chen Wei, monitoring the Deep Space Network communications from the Jet Propulsion Laboratory, initially assumed that the signal loss represented equipment failure or perhaps solar interference with the sensitive electronics required to detect the comet's faint emissions. The probability of simultaneous failure across dozens of independent observing systems should have been negligible. Yet every attempt to re-establish contact with 3I Atlas met with nothing but the cosmic background radiation and thermal noise that filled the empty spaces between stars. The optical telescopes provided the first confirmation that something extraordinary had occurred beyond simple equipment malfunction. Where 3I Atlas should have appeared as a bright smudge surrounded by its characteristic coma and impossible anti-tail, the sky showed only empty darkness punctuated by the distant stars of background constellations. The comet had not merely become radio quiet or thermally inactive, it had vanished entirely from the electromagnetic spectrum. As if the 12-kilometer nucleus and its surrounding cloud of gas and dust had been erased from existence. Yet, the gravitational effects of 3I Atlas continued to influence the trajectories of nearby asteroids and spacecraft, indicating that the comet's mass remained present even though it had become electromagnetically invisible. This gravitational persistence created a paradox that challenged fundamental assumptions about the relationship between matter and electromagnetic radiation. Objects composed of normal matter could not simply become invisible while retaining their gravitational effects. Yet, the observational evidence suggested exactly this impossible scenario. The regions of space surrounding the comet's calculated position displayed optical properties that seemed to bend and distort starlight in patterns reminiscent of gravitational lensing, but with geometric characteristics that followed the same dodecahedral symmetry observed in the nucleus structure months earlier. Background stars appeared to shift position and change brightness according to systematic patterns that rotated with the comet's 18-hour period, creating a zone of optical distortion that marked 3I Atlas's location even though the object itself remained invisible. Attempts to penetrate the electromagnetic silence using increasingly sensitive instruments and exotic detection methods met with consistent failure. Neutrino detectors, designed to observe particles that could pass through entire planets without interaction, registered no anomalous signals from the comet's direction. Gravitational wave observatories detected only the background ripples in space-time produced by distant astrophysical sources, with no trace of the structured gravitational emissions that had characterized 3I Atlas's active period. The silence extended beyond simple electromagnetic invisibility into more fundamental aspects of physical interaction. Deep space monitoring stations reported that cosmic ray detectors showed anomalous shadowing effects in the direction of the comet's position, as if 3I Atlas had become opaque to high-energy particles while remaining transparent to lower-energy electromagnetic radiation. This selective interaction with different forms of radiation suggested properties that transcended conventional concepts of matter and energy. The failure of detection attempts revealed the limitations of human observational capabilities when confronted with phenomena that operated outside established physical principles. Every instrument in the arsenal of modern astronomy had been designed based on assumptions about how matter and energy interact according to known laws of physics. When those interactions ceased to follow predictable patterns, the entire technological infrastructure of scientific observation became effectively blind to the processes occurring within the region of altered spacetime around 3I Atlas. Theoretical physicists propose that the comet might have undergone a phase transition into exotic states of matter that existed partially outside normal spacetime dimensions, If the nucleus had somehow shifted into higher dimensional configurations, it might remain gravitationally present in three-dimensional space while becoming electromagnetically inaccessible to instruments designed to operate within conventional dimensional frameworks. Such transitions would represent technologies or natural processes that exceeded current human understanding by centuries or millennia. The psychological impact of the Great Silence affected the global scientific community in ways that transcended mere frustration with technical limitations. For months, 3I Atlas had served as humanity's window into physics beyond the Standard Model, providing direct observational evidence that the universe contained processes and technologies that challenged fundamental assumptions about reality. The sudden loss of this connection to expanded physics created a sense of cosmic isolation, as if a door to deeper understanding had been firmly closed. International collaborations formed to coordinate attempts at re-establishing contact with the invisible comet, pooling resources from every major observatory and research institution on Earth. These efforts included experiments with quantum entanglement communication, attempts to detect exotic particles predicted by supersymmetric theories, and searches for electromagnetic emissions in frequency ranges far beyond the conventional radio and optical spectra that had originally revealed the comet's anomalous behavior. The silence persisted despite increasingly desperate attempts to penetrate the electromagnetic barrier that seemed to surround 3I Atlas. Each failed detection attempt added to the growing realization that humanity might have witnessed the brief emergence of technologies or natural processes that operated according to principles completely outside current theoretical frameworks, phenomena that had briefly made themselves observable before withdrawing into realms of physics that remained inaccessible to human instrumentation and understanding. Only took decades of increasingly sophisticated astronomical instrumentation to map electromagnetic emissions from objects throughout the observable universe. Only took centuries of technological development to create detection systems capable of observing phenomena across every known portion of the electromagnetic spectrum. Only took one impossible comet to demonstrate that the universe might contain forms of matter and energy that could selectively interact with physical reality. Becoming electromagnetically invisible while retaining gravitational presence and continuing to influence the structure of space-time itself. The silence continues as 3I Atlas moves through its invisible trajectory.